So welcome again, and thank you for joining us for yet another exciting session of Everyday Mathematics. A couple of announcements before I begin. The first is that we do now provide Python solutions to these problems at the end of the video. We also would like to thank our subscribers for being with us. We don't take you for granted. I also kindly request um, those of you who are here for the first or second time that have not subscribed to subscribe to our channel. So today we will look at two problems that pertain to logarithm in the regular season of the MIT 2023 integration B, and that is problem 11 and problem 12. So problem 11 was the integral of the square root of 2 log x plus 1 over the square root of 2 log x. It's an indefinite integral. Problem 12, which is the integral of logarithm of cosine x over cosine squared x. So we'll quickly jump into the solution. Solution for problem 11, which is the integral of the square root of 2 log x plus 1 over square root of 2 log x. So the first thing that I would quickly observe is I would look at this second component here, and if I really investigate and do a differentiation of the square root of 2 log x, first it's 1 over 2 the square root of 2 log x times the derivative of log x, which is 1 over square root of 2 log x over x. So if we look at this second component here, that is the same as x times the derivative of 2 log x. And then the first component there is the same as 2 log x times 1, which is 2 log x times the derivative of x. So essentially what can be done here is we can express our integral as the integral of the square root of 2 log x times dx dx plus x times the derivative of 2 log x. And so this is inside the integral here is the same as the derivative of the product of x and square root of 2 log x. And so when you integrate the derivative, you get the answer as x times the derivative and the square root of 2 log x plus the constant. And this is our answer. As simple as that. So next is the integral of log cosine x over cos squared x. I would like to convert this into sec. So I can convert 1 over cosine squared x into sec squared x here. And we know that the derivative of tan x is sec squared x. So I can express this integral as the integral of log cos x times derivative of tan x. And so using the integral of products, first we'll have the product of log cosine x and tan x minus tan x, the derivative of a log cosine x, right? And so that means that now we have log cosine x, tan x, then we'll probably subtract the tangent of x times the negative of sine x over cosine x. And that means that under the integral sign, now we do have a positive of tan squared x. So then what we can do is now we can use the identity of tan squared x plus 1 is equal to sec squared x. So sec squared x minus 1 is the same as tan squared x. So eventually now Under the integral sign, we have sec squared x minus 1. And as we know that sec squared x is the same as the derivative of tan x, um, which means that our answer is log cos x tan x plus tan x minus x plus a constant. And this is our answer. Okay.
So we're going to try to solve these problems using Python. And for those of you who were following us on the last problem, so we can start a Jupyter notebook online. And then in the cells, we just begin by typing. First of all, we want to import the NumPy library. Usually what we do is we import NumPy as NP, and then we import SciPy as SP, import SymPy as SMP, import matplot, not that we'll even use it, .pyplot as PLT, and then from the SciPy.integrate, we want to import library called board. From SciPy.integrate, we would like to import cumulative trapezoid. So let's see whether we're able to import this. It seems we have. Then we define x as a symbol, and how we do that is smp.symbols and x, and we want it to be real, true. So let's see whether that has been executed properly. So our function is the square root of 2 log x, square root of 2 times log x plus 1 over the square root of 2 log x, 2 log x. Okay. So let's see whether that has been executed. There is a problem. So that problem is the log function is not defined. You have to use an SMP here library to make sure that those are properly defined. And therefore it goes, yep. And so let's see what our function is. And as shown here, it is square root of 2 times square root of log x. So square root, this just goes in as 2 log, square root of 2 log x. And then here it's done some manipulation. We had a square root of 2 here that has been multiplied by square root of 2 on both sides, on both the numerator and denominator. So the numerator has become 2 and the numerator has remained square root of 2. So then we can go ahead and integrate f with respect to x. And let's see what that amounts to. So let's wait, it might take some bit of time. Whoa, look at that. So the answer is super complicated. I don't think, maybe by simplifying it, you could come back to the answer, but it's given us an error function, integral. Let's see what Wolfram Alpha does to us. Wolfram. So we can say, okay, we do want to integrate, and our first thing is the square root of 2 log x plus 1 over square root of 2 log x, okay, and dx. So let's see what that gives us. It's taking some time to compute. Okay, let's compute the output there. Well, it was able to decipher our problem well, and it was able to give us a correct answer, which is square root of 2 times x times square root of log x. And our answer was x times square root of 2 log x. So Wolfram here gives us a correct answer that we can decipher, but Python leaves us hanging. Now let's go back to the second problem. The second problem, we define it as function 2 is equals to SMP log of SMP cosine of x over cosine SMP cosine of x and the bracket, because I'm going to put to the power 2 there. And then let's run that. And it's taken it. So let's see what that has given us, and it's correctly deciphered it as we had expected. So the next thing I'd want to do is SMP integrate f2 with respect to x, and then let's see. Well, it's taking some time, but look at that. It's given us a very complicated answer, whereas I believe Wolfram Alpha would give us a more simplified answer. Let's try. So we said we wanted log of cosine of x divided by cosine of x squared, right? Let's see what it does. It's deciphered it properly, and it's given us the answer we expected, which is log x times tan x plus minus x. So sometimes, Python just leaves you hanging with these very long answers, but Wolfram Alpha has a way of giving you very concise answers. Okay,